to this online class. Today is the part 2 video of the chapter Force and Laws of Motion. I am 100% sure that you have watched the first video. If you haven't, then I will link it over here or in the description box. Please go ahead, watch the first video so that you can understand whatever is going to be explained today better. Okay, so we studied the first law of motion, and what was it saying? It said that any object, okay, will remain in the state of rest, or if it was moving, it will remain in motion unless an external force acts on it. Okay, so something was at rest, it will remain there forever if no other person touches it, hits it, or does anything to it. Okay, if there's no external force, it will remain there. Even if an object is moving, it should remain in that constant motion unless no force is acting on it. Okay, that's the first law. Based on that, we're going to understand something much more. So, more massive objects offer larger inertia. The inertia of an object is measured by its mass, and the mass of an object is measured by its inertia. So let's not complicate things with the entire statement. Let us understand with an example. So there is a boy who is trying to move a box, okay, which is maybe 5 kgs. He puts that force that he has, he's a small boy, right? So he's putting that force to move it, and he's not able to move that, which means that what is the box? If that box was actually a live person, you must have experienced this in your school time, where there is one boy who's trying to push everyone when going home, especially in that line, or in that P line where you want to move out. You're all in a line and someone is trying to push the other person, and there will be one person who is little bit on a heftier side, who will say tu and then he remains there, right? And the other person is trying to push him but not able to. So think of that logic here. Okay, so the object is trying to tell, it has the tendency to remain there. If that object is a little bigger, like a little hefty person, then it will still, like so that kind of energy tendency is there. So larger the mass of an object, the more mass that the object has, the more inertia that it has. Okay, so what is inertia? It is the tendency of an object to remain in the state of rest. And if like that the object was much bigger and 50 kgs, will not be able to move, right? This boy will not be able to push it, because why? The box is like, I have the tendency to remain here only and I will not move. So that is nothing but inertia. So I hope you are clear with this. Alright, let's move on to the second law. Now, I want you to observe each and every animation that is happening very carefully so that you understand the law better. Okay, now this is one boy and one dog looking straight up, and then they're close to a building, and there is one friend of theirs, a naughty friend you can say, who is on the 15th 16th floor. Okay, now and they say, oh, it's my friend ho raha. After that, what this friend who is on top does, extends his hand out from the gallery and then drops a table tennis ball, and that ball moves straight down, hits that boy, and then a table tennis ball, it pains a little bit. After a while, since that boy is still looking, this naughty friend, what it does, he throws one season ball. Okay, just extends his hand out and leaves the season ball. So what is happening now? First case, table tennis ball. Second case, season ball. Third case, what he does is, he leaves one big shot put ball on him. Now, it's just an example, okay? But you can imagine what would happen to this boy who's down there, poor fellow, if a season ball is dropped on him, okay? a shot put ball is dropped. Now, what I'm trying to tell you is there will be some kind of an impact. It will hurt, right? That this boy who is down with the dog will get hurt when each of these ball hits this boy. But in which case will that impact or the hitting will be more? Where will it pain more? Definitely in the case of the shot put ball, right? Because it is much more heavier. So now, then after a while, there's another person that comes in, another friend. So they're all three friends, and this one is a little bit more naughty. So what he does, this boy who is on top of the building, he throws a similar kind of a table tennis ball on him. Okay, he throws it now. He just doesn't drop it, but he throws it. In the first case, after a while, this boy who's down, he says, "Ah, woh mak duklo na tu kya ball." So what he says, he takes that another table tennis ball and he hits it with a lot of force. Okay, he throws it, aims at him and throws. So in the second case. Okay, so in this case where the two balls are being thrown, the table tennis ball, where do you think will be the pain more? In the first case when it is just thrown, or in the second case when it is thrown with a lot of force? Definitely you will say in the second case, right? That's the whole idea of the second law of motion. So what it says, the second law of motion states that the rate of change of momentum, okay, now the momentum in here in that example to understand is the impact. Okay, remember it like that. It is not impact, okay, but remember it like that. The momentum means how much is that impact, you have to understand, right? So momentum, you can, in this case was the impact. So in the first case the ball was thrown on that boy, it was hurting him, right? So it is dependent on what? That momentum word is nothing but it's a combination of mass and velocity. So mass into velocity. Here, I've written it over here, right, for you. Mass into velocity. Here, how heavy was the object? In the first case, I gave you example where that boy was throwing a different kind of ball. He was first throwing a table tennis ball, lesser mass. Second, he threw a season ball, little more mass. Third one was a shot put ball. So the mass was again and again increasing. If the mass is increasing, the momentum will be more. Why? Because momentum is based on the mass of an object and the velocity. So in all the first cases, it was just dropped. So velocity doesn't change. What changes is the mass. So I can give you an example that maybe just an example, okay. First case, the table tennis ball was say 2 grams, okay, 2 grams and with a velocity of 1 meter per second. So 2 multiplied by 1 will give me 2. In the second case, I can say that the season ball maybe was 100 grams. Okay, so 100 multiplied by 1, just thrown, right? So velocity remains the same. Still the impact will be more. In the third case, it's a shot put ball, so it is maybe of 5 kgs. So impact will be much more. Why? Because it is the momentum. Momentum is what? It is mass into velocity. Okay, velocity I have tried to keep constant. So what changes is the mass. So impact or the momentum will depend on mass of the object, or it depends on the velocity, or it depends on both of them actually together. So in the second case, when the other naughty boy comes, the ball was thrown. Okay, first it was just thrown like that. Second time it was thrown with a force. So the ball is the same, table tennis ball. So here in this case, the 2 grams remain the same. But what I'm multiplying, first maybe I was just throwing with 10 meter per second. Second time it is thrown similar kind of a ball with much more speed, right? So say 30 meter per second. So the impact will be more. Okay, so the law states that the rate of change of momentum of an object is proportional. Okay, it is balance, or it is equal, it is dependent. Proportional means something is increased, the other side also should increase, directly proportional to the applied unbalanced force in the direction of the force. So that first case the ball was dropped, right? Second case it was thrown. So these are the forces that are applied on that object. So the momentum depends on the force that is applied. So the more the force, the more will be the velocity of the object. So I hope you are clear with the second law. Okay, it states that the rate of change of momentum, what is momentum? Mass into velocity. It depends on two factors, that is the mass of an object and the velocity of an object. It is just like, when if a vehicle is moving, maybe a bike is moving and it hits a car, there will be a damage caused to the car, right? And if instead of a bike I get a truck and hit, so the impact will be more because the mass of the truck is more. So it's that law over here, second law of motion. All right, here is another example where there was a cricket match going on and a ball was tossed in the air for six, and then it comes and then this boy is trying to catch the ball. Now when he is catching it, the fielder, he doesn't hold the ball. No, he holds the ball and brings his hand down. You must have noticed this in many cricket matches. They hold the ball in this direction. Why do they have to move that hand from here to down? Why? Is That's the question. Why does the fielder, while catching the fast moving cricket ball, gradually pulls his hand backwards with the moving ball? So the reason is, okay, the fielder increases the time during which high velocity of moving reduces to zero. So if he was holding that, keeping his hand like that, ball is having mass, it has velocity. So that means it will have some momentum. Momentum, I told you, remember it as an impact. Now that impact on the hand will be much more because there's an obstruction, right? It is straight away hitting the hand and there's no movement. So it is suddenly the velocity which was there of that speed which was there for that ball suddenly comes to zero. Immediately, the moment it hits, it's zero. So the impact is entirely felt on the hand. But when you move your hand downwards, what is happening? You are giving that object so that that much of time to change. Okay, so that speed which was with it was moving, I have allowed it to lower down and come to zero within a span of time. So the time that you give, automatically the impact will be lower. Like for example, it's maybe a stupid example, completely different, but it will help you to understand the meaning. Maybe you did something wrong at home. Okay, you broke some container which was very precious to your mother, and now you know that if you straight away go and tell her, mama, I broke that certain container, then you are definitely going to get beating, impact, momentum. Okay, so what do? You just go to her and then say, mama, if that container was not there with you and if it was missing, how would you feel about it? And then mama says, nah, I will feel bad. And then you are giving her time to reduce that impact. I hope you are able to understand the meaning of this entire example that I'm giving in relation to this example of the cricket ball and the fielder. So the more time you give, the impact will become lesser. Because remember this, force is nothing but mass of an object into the acceleration. The force is dependent on that mass into acceleration. What is acceleration? Formula for acceleration is final velocity, that is v, minus initial velocity u upon the time. So if acceleration has to be more, then that change has to be faster in very less span of time. And what is done? The t is multiplied on the other side, and ft, that is force into time, is equal to mv, right? Mass into velocity. What was it? Momentum, right? So that impact is dependent on force and the time. So you increase the time to reduce the impact. Explain how a karate player can break a pile of tiles with a single blow with his hand. Now, this you can answer in the comment section, or you should be able to answer actually knowing the second law of motion. In case you don't know, then let me answer for you. Okay, because a karate player strikes the pile of tiles of a slab of ice with his hand very fast. Okay, so a large momentum. So when he is hitting, right, mass, and we are giving velocity. So the moment, if you want the impact to be more, what should happen? The You should convert that entire momentum immediately to zero, then only the impact will be higher, right? Or if you just say, okay, I'm going to break this tile and I'm going to get my hand and slowly dheere se, if you're going to hit, there won't be any impact, right? So for the impact to be higher, the mass of the object and the velocity has to increase, because momentum is nothing but mass into velocity. So the large momentum which is there of the hand is reduced to zero in a very short interval of time. You don't give much of time to it. You immediately reduce it to zero. That's when the entire pile breaks. Otherwise, it won't break, right? So remember that. Mass into velocity. The whole idea of the second law is to tell about momentum and the force. Okay, so momentum, the rate of change of momentum is proportional to the force that is being applied. Again, you can remember there's someone, a boy trying to push a 5 kg box. He's moving it for a while, for a few seconds, and then he is moving it for a little more, and it moves a little faster. So, a constant force acts on an object. It's a question for you to solve, okay? A constant force acts on an object of mass 5 kgs. Constant force is who? The boy pushing it, okay? For a duration of 2 seconds. So, he pushes that object for 2 seconds, okay? It increases the object's velocity, the object which was moving with a 3 meter per second. Because he applied that force, it moves at 7 meter per second. Okay, you are asked to calculate, find the magnitude of the applied force. How much force was applied so that this object which was moving with 3 meter per second is moving with 7 meter per second velocity. So for that, to calculate for this entire problem, to get an answer, all you have to do is use a formula like this. So force is equal to mass, which is 5 kgs, velocity. There is an v and there is u, right? When v is nothing but final velocity, u is initial velocity upon the time that they have taken. Okay, so use this formula, substitute all the values, and you can get an answer. Whatever the answer you get after calculating, please don't forget to write it in the comment section so that we can check the answers. Okay, now the continuation of the problem. If the force was applied for a duration of 5 seconds, that means initially he pushed it for 2 seconds. Now we are increasing the duration of force that he is applying for 5 seconds. What would be the final velocity? How fast will the object move now? That is what we are trying to calculate. So after you have calculated the entire problem, all you have to do is change the duration of time to 5 seconds and then understand what will be the result. Alright, let us continue with the third law and conclude this video. Okay, so there is an egg and I take another egg and hit the egg. What will happen? Egg will start cracking, right? And only one egg will crack? No, both the eggs will crack. So what is the third law of motion telling us? The third law of motion states that to every action there will be an equal and opposite reaction. These examples, I'm sure, should be able to help you understand the entire sentence, that entire law, into a meaningful information in your mind. Okay, so to every action there is an equal and opposite reaction. I'm sure that you don't go and see the law in the eggs, but do you experience this law in day-to-day life? Of course you do. If, for example, there was no equal and opposite reaction, do you think your vehicles would move? No. Keep the vehicles aside. For example, if you want to push, maybe a cupboard, okay, which has a lot of matter inside it, and you want to move that cupboard, and you are trying to, the first thing that you actually try to do is grip your legs into the ground properly, right? You find some support and then you grip your leg. Why? Because when you are pushing, there is an equal and opposite force, right? So you are trying to take that support, what you usually say, as an external, the opposite direction force. Then only you'll be able to push it, because there is some obstruction. That's why you dig your legs in a place and then you try pushing it, so you are taking that external opposite force. Example of a vehicle. Now, when the tires are rotating, because there is an external opposite force, which is trying to stop the tires from moving in that direction, then only that rotation happens. If there was nothing to stop, the tires would have kept rotating over there only, and you would not be able to move. So, the third law is this. So, to every action, there is an equal and opposite reaction. If you have understood all these three laws perfectly, okay, which I hope you should. If you haven't, then please watch the video again to understand the laws properly. Then the entire part of this entire chapter is all word problems to solve. You should know the laws properly, and if you have understood, you will be able to solve word problems very easily. Things to remember when you're solving word problems. First of all, ask yourself the question that I'm reading, to which law is it applicable? If you're able to relate the law, relate the problem to a law, then you will be able to understand it and able to solve it properly. Okay? I hope you have understood whatever I explained till now. If you did, then please don't forget to hit the like button. Share this video with your friends so that they also can learn force and laws of motion very easily. Okay? And subscribe to the channel if you haven't, because I see a number of my viewers don't subscribe to the channel. So please subscribe, and until then, take care and bye bye. God bless you.